This is problem number 6 from the H10-4 homework. The directions state write the following series in summation notation and find the sum or expression for the sum. And actually in this one we can even ignore that part of the expression because I made sure that each of these would have a sum since we were just getting into it. So let's look at letter A. It says 7 plus 9 plus 11 all the way up to 71. Okay, so before we take it and we try to find the sum or try to put it in the summation notation here, let's take it and look at the information that we've been given first. Okay, we know here the first term, that's been coming into play whether we've been finding the equation for the nth term or we've been finding the equation for the sum, right? So our first term is 1. We know the common difference here is going to be 2. We're adding 2 each time. And then we don't know what the term number is for the last number, for 71. So that pretty much means then that we don't know how many terms there are. That's going to be one of the things we're going to need to find first. So in order to do that, let's use our equations. Remember, we've got two different kinds of equations. We have the a sub n equation, right? That usually starts out looking like this with the first term plus the common difference times n minus 1. This helps us to identify term numbers and terms, right? That's like the explicit equation you learned from Algebra 1, but it's just in first term form. Then we also know this formula here. This is the sum for n number of terms in an arithmetic series, and it goes the first term plus the nth term, or last term, times half the number of terms. We're going to need all of these formulas to be able to get all of the information they're asking for in these problems. So first thing here, let's focus on using this one. This one's going to help us find the number of terms and the argument. Okay, this one helps us find the number of terms, or n, right? And it also helps us find what the argument is, because actually this right here is the argument for our summation notation. And then on the other side over here, right, this one is going to, just help us find the sum in the end there, right? So that one we're going to focus on finding the sum from that equation. So jumping back over, okay, let's do this here, right? Right now we know that our a sub n is equal to 71. So if we're thinking about that equation, that a sub n equals a sub 1 plus a common difference times n minus 1, we're going to take it here and we're going to say, well, let's just find that general form first, okay, without actually finding the 71. We know that we can find the term number for any term by plugging in our first term plus our common difference times n minus 1. And right now, what you see on here, when it's just equal to a sub n, this is the argument. Okay, this will be the argument when we are writing out our summation notation. Now, this is not the simplified form for it. We could take it and simplify it down as well, right? We could distribute our 2 through here, and we would have, what, 7 plus 2n minus 2, and that would give us then 2n plus 5, okay? You could also use this as the argument, okay? It's just the simplified version of the same thing. So the argument could be either of those. Now, let's go ahead here and figure out how many terms there are. We'll say here that our a sub n, right? Since a sub n is 71, we'll put that 71 in. Now we're just looking back up here kind of at this part. 71 is equal to, we'd say 7 plus 2 times a quantity of n minus 1, and we'd solve it. Okay, so distribute our 2 through. We have 7 plus 2n minus 2, and then we have 2n plus 5 is equal to 71. Well, what do you know there, right? Isn't that the same as this expression right here, right? So you could also just take that 71 and set it equal to the argument and then solve it for the number of terms, right? We subtract our 5 from each side there. That gives us 66 is equal to 2n. So we know the number of terms in this is going to be 33. So we have 33 terms. 71 is our 33rd term. Okay, 7, remember, is our first term. So since we know our first term and our 33rd term here, we can take this and write this in summation notation. Let's do that. So remember to write it in summation notation, right? We first start with sigma. We draw that out there first. We need to choose a variable. I'm going to say, let's just use x. That one's fine there. So we're going to say x. Actually, you know what? We've been writing n. Let's just write n. Let's just do n. I don't want to confuse you. So let's just use n. I probably did confuse you there by doing that, but I'm sorry. So we're going to start with the first term, right? And we're going, so this is our first term, and we're finding the sum all the way to this term, which is our 33rd term. So we put 33 on the top. So remember, those are term numbers. Our argument here will end up being, we'll just put in the 2n plus 5. If you wrote this one in here, if you wrote that one in there, it's still correct, okay? But I want the simplified version. It makes it a little bit easier. So the sum from our first term to our 33rd term of the numbers that follow this pattern or this rule, okay, is going to be, and we can figure that out now. We're going to say the sum of 33 terms is going to equal our first term 7 plus our 33rd term, which was 71. And then we're going to multiply that by half the number of terms, which would be 33 over 2. Well, 7 plus 71 is 78 times 33 over 2. Well, remember, that's like we could take the whole thing over 2, and we can reduce this. So 2 goes into 2 once, goes into 78 39 times. And that doesn't help me for mental math. We're probably going to have to pull out the calculator. So let's just do that real quick. Let's do 33 times 39, 1,287. So the sum of these, all right, there you go. Sorry, it fell asleep on me. Sum of 33 terms is going to equal, and now I forgot it, 1,287. And that is the sum of that there. So we can say this equals 1,287. That is the answer for the first one. Let's go into the second one now. Probably less explanation, more just doing it here. Okay, so the first thing we got to do is figure out what term number 32 is going to be. We know this is our first term. So we're going to say here, a sub n is going to equal our first term, negative 100, plus our common difference. Our common difference here, it looks like it's increasing by 22 times n minus 1. How did I get that? Well, that's the difference here, right? We're going up from negative 100 up to negative 78, up 22 more to negative 56, and so on. So it's increasing. So our a sub n, let's just go ahead and find the simplified argument first. Negative 100 plus 22n minus 22 when we distribute that through. And then that looks like it's going to be 22n minus 122 is going to equal our a sub n. That is the argument. Okay, now let's just find then our value for n for 32. Let's just put 32 in here, and let's just use, on this one, we use that simplified argument. We're going to say 22n minus 122, and now just solve it for n. So we've got 154 is equal to 22n. We divide it by 22. And it looks to me like that would be what? I think 7 is the number of terms. Okay, so how does that help us? Now that we know it's 7 terms, we can take this and we can start writing out our summation notation. I'm going to do this one down here. I know that my first problem limited my freedom here to write, but I know that I'm going to go from the first term, we'll say n equals 1, all the way to the 7th term, and our argument here is 22n minus 122. So the sum from the first to the 7th term of those values. So when we compute those values, we're going to say the sum of those 7 terms is going to equal negative 100 plus 32 times 7 divided by 2. Well, negative 100 plus 32 would be negative 68. And we're going to multiply that by 7 halves, so we can go ahead and reduce that. That would be negative 34 times 7, which would be sum of the first 7 terms. 7 times 30 is 210. 7 times 4 is 28, so that looks like 210 plus 28 would be negative 238. And that is our sum. So there is our final answer there. Hopefully this is making sense. If not, you need to make sure you're reaching out to your teacher, whether it's me or Mrs. Green. All right, so the third one here, right? Let's start out here again. Need to figure out how many terms there are going to be. We'll find our argument too, just like we've been doing. So we'll say a sub n is going to equal our first term 5 plus our common difference, which is positive 5 times n minus 1. So let's finish getting the argument here. This would be 5 plus 5n minus 5, which gives us just 5n. That's nice. What a nice argument. So a sub n is equal to 5n. Remember, this is our argument here. Now let's plug in our 55 and solve for the number of terms. We get that n equals 11. So the number of terms right now we have is 11. And since our 5 is our first term, and this is our 11th term, right, we'll go ahead and put those into our sigma notation, or our summation notation. I'm going to use n again because it's flowing well with the n's. So we're going from the first term to the 11th term of the series that's defined by that expression, 5n. And the sum we will get will be, sum of those 11 terms is going to equal 5 plus 55 times half the number of terms. That's going to be 60 times 11 halves. 60 divided by 2 is 30, so 30 times 11 is going to be 330. So this equals 330. All right, hopefully you're feeling good about it here. We got one more to do from this section. Let's do it here. We need to figure out the number of terms. We know this is the first term. So a sub n is going to equal 115. Now this one, notice it's going down. So we're adding a negative 3 each time. So, and actually let me move this down just a hair. Sorry about that. So we have a sub n equals 115 minus 3 times the quantity of n minus 1. Remember, this is where the number one mistake in Algebra 2 comes from, where we are distributing negatives through. Make sure you're careful. So a sub n equals 115 minus 3n plus 3, because we've got to distribute the negative. Now we've got negative 3n plus 118 is equal to a sub n. There's our simplified argument. Okay, and now we can figure out what the term number is for 82. Oops, let's use the thinner marker. So 82 is equal to negative 3n plus 118. We subtract that. And 82 minus 118 would be 18 plus 18 would be negative 36. It's equal to negative 3n. We divide by negative 3 on each side, and we're going to get there are 12 terms here. So we're finding the sum from, sorry, it froze up on me again. We're finding the sum from the first term to the 12th term. So we write out our sigma notation, or summation notation, sorry, it's known as both, and I'm used to saying both of them there. So we've got the first term to the 12th term of our argument, which was up here, negative 3n plus 118. Then we just find our sum here. Our sum would end up being, so the sum of those 12 terms is going to be our first term, 115, plus our last term, which was 82, and then we're going to multiply it by 12 divided by 2. 115 plus 82 would be 197. And we're going to multiply that by 6. And we'll get the answer here. I'm just going to use the calculator to make sure I don't botch the last one. So 197 times 6, 1,182. That would be our answer here, 1,182. And we'll take it there and box it in. That is it for question number 6. Oops, get off of there. Question number 6 from the homework there. Those are your answers here. I'll try to make them stand out a little bit more here if you're just checking your answers. If you have questions, you know what your job is. Don't be lazy. Ask. Don't be scared. Ask. Do what you got to do to make sure that you know what's going on. You have the power. All right. Thanks for watching.